Alright, today let's solve Leetcode number 200, number of islands. So basically you've been given a matrix representing with 0 representing water and ones representing land. So if you have ones surrounded by all water, then you are having an island, right? So in this case where we have all of these ones grouped together surrounded by water, and we can safely assume that there's water all over this, but all the boundaries around this one is water, so it makes this an island, right? Because water is all over it. This is a graph. This is an adjacency matrix. So let's see how this can be represented so it can give us a clear picture of what exactly we are looking at. Right, so we have 1 1 1 0 1 1 1 0 1 0 0 0 1 1 0 0, and then we have zeros all over here. Now we can also denote each column, like index it. And then we have 1 2 3 4. Now with an adjacency matrix we can say that we know that there is an island 1, so that's 1 here. We know that 1 has a connection with 2, so we can go to island 2 from 1. We know that 1 has a connection with 4, so we can go to 4 from 1 and vice versa. And then we know that there is no connection between 1 and 5. Now there's also an island 2. We know that there's a connection between 1 and 2. That connection is already there. We know that there is no connection between 1 and 3, so there's no connection between 2 and 3. Between 2 and 4, however, there is a connection, right? So we can go to 2 from 4, and then there is no connection between 2 and 5. Now 3, we know there's a connection between 3 and 1. So we have 3 here, and then there's a connection between 3 and 2. Oh, so there is a connection between 3 and 2, and then there's no connection between anything else. Right, am I missing something? 1 2 3 4 5. So we know that we can establish connections between all of these ones, right? There is a connection between all of them. 1 2 3 4 1 2 3 4. There's nothing here, so 1 2 3 4 5. Yes, so the island, everything else is water, and you can get to each of the islands that we have here. You can establish a connection between them. There, you can go to 1 from 2. You can get to any of them, right? There is a road or there is a link between them. So this, as you can see, all of the islands are connected in some way or in some shape or form. You can get to them in some way, shape or form, right? So there's only one, and you can get to all of them. Now let's look at the second example that says that has 1 1 0, 0. It has 1, 1, 0, 0, 0, 0, 1, 0, and then we have 0, 0, 0, 1, and then we have all zeros here, and then 1 here. Now let's index it like we did that one. 1, 2, 3, 4, 5, and then you have 1, 2, 3, 4. Let's look at how this graph will look. We know there is an island, there's a land 1 here, and 1 has a connection with 2, and then 1 has no connection with anything else. Now we know there's an island here, right? And this island 2 has a connection with 1 that has already been established. This island 2 exists. Now we have an island 3 that has a connection. It stands alone, doesn't connect with any other island. And then we have island 4 that connects with itself, and then it connects with 5, right? So 4 gets to 5. Now, as you can see, there is a connection, 4 and 5, right? So how many islands can we count here? You can get to this one. This is surrounded by, see, 1 to 2. So this is the first island here, 1, and 3 stands alone, 2, and then there's a 3. So we can see that we only have 3 islands, right? So basically, if you are standing here, that's basically what the question is asking. Can you get to all of this, right? If not, what other island exists and what other connections, what other node or nodes can you get to? So with this one, we can get to this. We can get to only this one stands alone, and then we can get to these 2 lands. So that is how we establish the 3. And you can see we can draw it out here. There it is. And here we can draw this here. We can draw this here, and then we can draw this here. So we have the 1, the 2, and then the 3, right? And we can use DFS or BFS to get to it. You get to one point where you know it's a 1. What other cells can you reach? You can reach this one, you can reach this one, you can reach here, you can reach here, you can reach here, you can reach here, right? So you find a spot that is a land and find how many other lands you can reach from that spot, and then you count it as 1, right? So let's look at how we can present that in programming in Python code. So let's look at how our refs search function will look like. So let's do a BFS here. It's going to take in a row and a column, right? I'm going to set up a queue, and then we are going to append our row and column into that queue. Set up a visited dot add row and column. So we need to set up variables visited, that is a set, and then yes. Now at any point here we need to go left, right, up, and down to determine if it's a land or it's water. So so while queue row and column is equal to queue dot pop left, right? So for the x, y in 0 0 1 minus 1 0 0 minus 1. So let's call this an adjacent row is equal to row plus dx, and then the adjacent column is equal to column plus dy. Now, to even proceed, we need to establish that this coordinates, right, these indexes, row and column indexes, are within range. So if so if it's within the range of 0 and then the length of the rows in the array, which means I need to set up rows which is equal to length of grid, and then the columns is equal to length of grid, so it has to be within range. Same thing for the adjacent column. Okay, and if we have not already visited, right, this adjacent row and column, so I think this is going to be something long, so let me get it this way. And grid if all of this is true, first, we've not already visited it, right? If we get in here, we go here. If we have not already first of all, it has to be within range. We have not already visited it and it's equal to 1, then we need to add it to the queue. And it has not been visited. We need to add it as visited first. Well, it doesn't really matter. And then we need to append it to the queue as well. Then we can return. So this is the DFS function that is going to perform our DFS traversal. Let's not forget. So now we are going to write the function that calls the DFS to get us our number of islands. So for row in range rows, and for column range columns, if grid row call is equal to 1, a string of 1, and it has not been visited. Let's do a DFS on that. And then increment island count by 1, which I haven't set up, so let's do that. And then we return island. Basically, we get to this point, traverse, we get to this point, find out how many other lands we can reach from this one, and then we try again to find another one spot that has not already been visited, and look at how many lands we can touch. Here we found one, which is the first one, and we realize that we can touch all of them. If we come in here, this would have already been visited, this would have already been visited, so there will not be any need, and this is it. But if we get here, we know we can reach this, we can reach 2. That is the only one we can reach. So we can get to this spot, and we know that this one is a standalone, it can't reach anything. And then we get to 4, we know that 4 can reach 5. Okay, so let's see if I don't have any spelling mistake or logic errors. This should be fine. Okay, so it's BFS, not DFS. Hopefully that is. So the q.append, yes, this should be a row here. Right, so that is it. This is how you solve number of island Leetcode number 200. Thank you very much. See you in the next one.